So I was asked to talk a bit about ICS security. I'm the creator of a ICS honeypot called Conpot. But I knew that I have the last presentation, so I kept it a bit in a tongue-in-cheek style. There's a bit of provocative comments in there, so don't take it too serious, but I hope to also convey a couple of critical comments. So you probably remember Robert saying that most of the incidents in critical infrastructures don't happen through cyber attacks or terrorists dropping a plane on it, but the biggest reason is squirrels biting through cables, or sometimes even people shooting substations. So physical attacks against facilities. When you talk about ICS and ICS getting more connected, and all of a sudden you see showing so many ICS devices being connected straight to the internet, and you can discover them, you can probe them, you can play around with them. That means that things get more connected, and when things get more connected, they're more available for people to control them, but they're also more exposed. You might not be familiar with how the ICS industry is changing with things being more connected and more accessible, but you might be aware of the Internet of Things. So where all of a sudden your fridge has an internet connection, the fridge might know what happens inside it, can tell you, hey, you might want to bring some milk because you're running out of milk. So what is the Internet of Things? It's basically everything becomes an API, so it can you can read from it, but it also is able to reach out and pull data in. So the fridge might be able to tell you, hey, I know that Target has currently cheap milk prices, and you might want to go to Target to fill up your milk stores. So, but what does it mean if everything gets a bidirectional API? This means that things get exposed. And so we have the same problem with ICS or SCADA security, that things get more exposed, and people have to struggling around with how to protect it properly, because there's new devices. The devices might not be able to protect themselves, so we have to build a protection layer around them. So I like to call ICS the Internet of very old things. It is very polemic. I'm trying to be a bit controversial here, but basically, I don't know if you remember back in the days when your grandmother got a telephone line maybe, and all of a sudden she got those weird calls from their nephew needing some money. Or how your parents got internet access, they got emails from a nephew needing money. I kind of see that ICS is going in the same direction. So all of a sudden there's an internet connection, and maybe someone asking from the outside, hey, you need an update, I got an update for you. So while everything around ICS, the IT infrastructure and how we do IT is moving really, really fast, everything is a small container, everything can be destroyed and restored really quickly, ICS is still something that's slow, that needs a long time to adapt to things. So I consider the whole smart factory, so what we call in Germany the Industry 4.0, not a revolution when it comes to the technological aspect, but more a revolution on how people are using it. The technology is not really revolutionary. I mean, connecting things to the internet is nothing new. We do it since 20, 30 years. But how the people are using those devices and how people are connecting them and protecting them, that needs a revolution. The people who are all of a sudden are exposed to, hey, all the things are open and I have to protect them. They have to adopt how they do security and how they do their ICS infrastructure and setups. So I said before, those are machines, they work, and all of a sudden they get a network connection. So what used to be a serial connection gets a serial to Ethernet converter and gets plugged into the internet. This is, again, formulating very simple, but The problem here is that things get connected, and especially things that have no authentication because they never needed authentication. I mean, something that is not exposed or is only accessible by someone already authorized doesn't need authentication. So there's no lock on the toilet because you're already inside the building. But if the toilet gets an out-facing door, so if you all of a sudden are able to access the toilet from the outside, then it should get a lock. The problem now is that all those vendors for ICS devices, they need some time to adopt. They have to adopt to the fact that their devices are connected to the internet, that they're exposed. And that means they have to update protocols. They have to implement new protocols that are able to do authentication. They have to update firmwares. They maybe have to close down certain features that are required in a certain context. So then the next step is life cycles of how things happen. So how the life cycle update, life cycle of an update, vulnerability report. So if I report a vulnerability to an ICS vendor, what do you expect how long it takes until they fix the problem and ship it to their customers, and every customer has upgraded their devices? It takes a long time. It's not like Facebook. You go to Facebook, say, hey, I found this cross-site scripting vulnerability, and Facebook says, yeah, here, nice, there's $10,000, and we fix it, and the next day it's fixed. Because for them, it's easy. For industrial control systems, it's not easy, it's not simple. Especially when it requires from the users, the customers who use those devices to maybe buy a new device because the old one cannot be upgraded. So why do we connect things? Why do we want to make our factory smart? It is basically very natural to do it. I mean, if you know how things are moving inside your factory, if you know when certain resources are required, that gives you a huge advantage. You can calculate much more quicker when to buy new resources, when to start a process, when to stop a process. So just imagine every sensor, everything that controls a factory, every small valve can be seen and controlled from the outside, or controlled in a single space, or is producing large amounts of data that you can analyze. You can all of a sudden see how things are moving in real time. And that's amazing. That gives you a lot of control over the whole system. It lets you optimize things. You can control where a certain task is going. Should it go to the facility on the West Coast, or should it go to the East Coast? Because you know exactly what's happening. Maybe everything goes up into the cloud and you have a central place where multiple factories are feeding their data in one place. You can compare them with each other, and you can optimize exactly where things are flowing. So it is absolutely natural that we start connecting things. See it as a big network of things. And when it comes to factories, when it comes to industrial processes, it should be real time, it should be fast, it should be quick, it should be reliable. I mean, if all of a sudden a data source disappears, you're flying blind. You don't know if you should turn off the heat or turn up the heat, or then it gets critical and then things can blow up. So you have a network of sensors that are collecting data, and it should be as reliable as possible. And that's a really complicated thing to protect. So a couple of months back, we posted an article through my company about industrial security, and it was a very high-level article just saying, yeah, maybe we should just introduce more traditional IT security into industrial complexes because, yeah, as you have heard, there's configure infecting nuclear reactors, there's all kinds of traditional malware infecting and impacting critical systems. One of the comments was, no, you cannot make vulnerability scans on the system. Because what happens if that triggers a firmware update or reboot and something breaks? And for everyone else who's not working in industrial facilities, this sounds stupid because, I mean, if you cannot scan something, you don't know if there's a vulnerability. And if something breaks because you scan it, I mean, scanning is not probing and stabbing it, it's just like touching it from the outside. But if that's not even possible, how do you know what you're exposing? But for those people, they handle devices that are built for one single purpose. They're super good at this one single purpose. They don't break, they don't go down, they're always there. But if you handle them in the wrong way, they might do something completely out of your control. And that's another problem that those people are facing. And we have to find ways how we can still do the vulnerability assessment without them being in fear of you breaking their stuff. So another comment on this article was, we cannot do network security monitoring, antivirus or patching vulnerabilities, vulnerability scanning or any other kind of security measures because the system is critical. AV means there's something that scans things, maybe that is impacting your CPU, maybe it's all of a sudden putting something in quarantine so you cannot access it anymore, maybe it deletes a file that it considers to be malicious. Maybe that file was critical, maybe it was required for a process and all of a sudden the process goes down and the whole facility goes down and it costs millions because there's downtime. And that is critical, and they would rather have a virus, a configure spooking around in their Windows machines, which is not critical for their operation, as long as the whole facility is running and producing products. So it is not as easy as just saying, just deploy traditional IT security and we're done and the problem is solved, or patching those old Windows XP machines. We have to keep in mind that they have a different requirement to what their systems are supposed to do and how they're behaving. This is an older comment, but it kind of reflects the mindset. So most public utilities rely on a highly customized SCADA system. No two are the same, so hacking them requires specific knowledge. And this is true. I mean, most of those systems require some knowledge about at least the protocols, the architecture of such an industrial facility. But as you have heard before, most of those APT attacks work in multiple stages. Where the first stage is getting inside, which is usually trivial, using spear phishing or using traditional malware, using some exploits that still work on Windows XP. And then when they're inside, they have enough time to do their recon. They can see how the system is built, what kind of protocols are used, and then do whatever they want to do. So I don't think this is something you should rely on. And I think people are smart enough to figure out those protocols. I mean, especially if the protocol is in clear text and not authenticated. So what we're facing here is kind of an arrogance and blind certainty. So that means people are kind of so certain about things are way too complicated for someone to break in, or they got an air gap and it's impossible to pass this air gap because it's an air gap. I mean, how do you transfer something across an air gap? But there are so many ways and so many examples where this air gap has proven to be not really useful or actually kind of helping others to get inside, especially this Struxel example where the air gap forced him to use USB sticks, and that requires them to have USB sticks lying around to transfer logic from the engineer's computer inside the facility. So they had to use USB sticks because the air gap prevented them from transferring them directly. So air gap is something that works in some cases, but not in every case. And this certainty, if you're certain that something is impenetrable, that makes you kind of blind for the actual threat. So instead of being certain that something is impenetrable, you should be in a position to say, okay, I know this is my exposure, this is the potential ways how someone gets in, and I have to protect myself from those weaknesses which I'm aware of. The next problem is the lack of education and professionalism. So people in this space, they work with machines, they work with heavy industry, and they might not know the latest trends in how spear phishing is working, how malware gets inside the system. They're not security experts. So they have to be open for someone else telling them how to do things, but at the same time, we have to be open that things are not as easy as we think they are. They have different priorities. It's not, they can shut down the whole system because there's a virus. They cannot isolate the system because it's infected. Just because it's infected doesn't mean that the factory is not running anymore. So they might tolerate something that's infected if the system is still running. So I've stolen this small story from Kara. It's about World War I fighter pilots. So in the first couple of months when the Germans and the Allies clashed inside the air with their planes, the Germans managed to shoot them down all the time. It was easy for them, apparently. They kind of had the same technologies, so regular planes, same guns, no different calibers, and the Germans kept shooting them down. It was easy. They just picked them from the sky. And they couldn't understand what's happening. And after they went back and analyzed what's going on, they found out that the Germans had the proper training before going into war in planes. So going to war in planes requires a different perspective on the situation. As a regular soldier, you're on a flat surface, more or less. You see things in front of you, in the back of you. You shoot something that's in the front, you don't shoot something that's in the back. In an airplane, you have to see above you, so you have to see below you, in front, behind. An enemy can come from every direction. And if you have the proper training to have this awareness, you can defeat your enemy. And then things turn around. So if you're aware of your surroundings, if you're aware of what you're exposing, if you're aware what your vulnerabilities are, you're in a position to protect what you have to expose. And if you don't have to expose it, then just shut it down, turn it off, or patch it or replace it. It doesn't make sense to protect something that you're not really exposing. I mean, it probably is helping, and it helps maybe if someone gets inside and gets closer to it. But focus on the things that you have to expose. Focus on the things that are on your perimeter. And that means make sure that configure doesn't get into your system, or your system is not vulnerable for configure. Because if something gets inside, then even the best perimeter protection is not helping anymore. If your inside is vulnerable to something that is defeated since 10 years, then it's easy to move around inside and discover how you protect the outer perimeters. Compartmentalized, that means basically putting things into different boxes and protecting the boxes from each other. Making sure that you see if something wrong happens in the box, and make sure that moving between the boxes is difficult and at least monitored. This is something that is kind of done by a lot of industrial systems, so they have their multiple layers. They have the DMZ, where they have their websites and whatever they expose to the public. They have their business layer, where management is sitting having their Windows computers. They have their engineering layer, where the engineers writing their programs for their PLCs, and they have the PLC layer. Everything is kind of compartmentalized, but still there has to be connections. I mean, things have to flow through these different layers. And as soon as things are flowing, those are the points where you should implement protection. So whenever we talk about security, people say, or vendors sell you something that is protecting you. It might protect you, but until a certain point when this protection fails, and it will fail at one point. It's impossible to protect against something that you don't control. And you have to be aware that if something breaks, you have to be able to trace back how this breach happened. You have to be able to identify what got leaked out of your system and how big the problem is. And knowing what happened allows you to identify first the weaknesses, identify where you failed, and then also recover. Recovering means what are the things that I can still trust, what are the things I have to replace. So when something is unprotectable or something is not patchable, put monitoring around it. I know monitoring means that you're collecting data, and collecting data means that someone has to look at the data and analyze it. And as you heard in previous talks, this is the actually difficult part. Setting up network monitoring, setting up a tab and feeding the data into a database, that's simple. That requires a couple of days, but looking at the data requires knowledge. It requires the ability to filter out what is irrelevant, what is not important, and know how to act on something that is relevant. And that's a really difficult part. That's where you require a lot of knowledge, a lot of experience. So you're evaluating what you observe, and this is the point where you get the biggest impact out of your security monitoring. This is the point where you get the most value out of setting up honeypots. I mean, if you set up a honeypot and it's just idling there collecting data, it's useless. Then just turn it off because it might have a vulnerability and you're exposing more than you want. So when you evaluate your data, you get probably a couple of points out of it that might indicate something that's bad. But then having also the ability to act on those points, that is the final step that you have to acquire to shut down a problem. So finally, as another short story, I have a small niece, and whenever I have the honor to bring her to bed, she starts telling me things, starts showing me things, and that's basically her way of doing social engineering to extend the time she can stay awake. And this is just a really good example how we all are experts in social engineering. Everyone here knows exactly what to do if they want something from someone. You just have to smile, you have to be friendly, and it's easy. And that's how phishing is working. And everyone is really, we have really bad protection against this kind of social engineering. Everyone tries to be nice and tries to respond in a nice way, and okay, I click on the link, or okay, I reply to this African prince and tell him, hey, I'm so sorry about what happened to you, and I would like to help you, but I cannot help you. And this is how the conversation starts. I mean, you probably notice that it's phishing, but you still want to be nice. Maybe you still are kind of interested in what's going on. So social engineering is always the weakest point, and Lance said that multiple times that if you don't know that you are the weakest link in the whole system, then protecting and spending a lot of time on protecting your system is kind of futile. I mean, if something gets in your system through people, then nothing protects you. There's not even a trace. I mean, if someone carries a USB stick into the deepest layer, into the PLC network, there's no trace in between. There's nothing in the DMC, there's nothing in the business layer or the engineering network. It traverses invisible into the deepest layer. There's no monitoring down there. I quickly want to introduce a bit of deception. My honeypot, the industrial honeypot we write at the Honeynet project. I used a small equation to explain roughly what a honeypot is supposed to do. So security risk, the risk of a thing that you want to protect, can be described as a function of the likelihood of a successful attack and the consequence of that attack. So if you combine those two elements, and that kind of describes the security risk for something. So if there's no way that an attack can be successful, then the security risk is almost zero. If the consequence of an attack is zero, then an attack might be not considered to be successful at all. So let's have a look at the likelihood of a successful attack. So I like to describe the successful attack as the threat that's against your thing that you want to protect, then vulnerabilities that might be exploited and can be used to break into your system, and the last part is the target attractiveness. So if there's no threat, if nobody is going to attack you, if nobody is interested in attacking you, or if there's no bad guys out there, then there's no likelihood out there that you get exploited. If there's no vulnerability in your system, you're fine, nothing gets inside. If you're not attractive enough, nobody will touch you, so nothing happens. So in the honeypot, we kind of want to tweak some of those things. So we want to increase, for example, the target attractiveness, because we want to see cool stuff. We want to increase the number of vulnerabilities we are serving. The threat is kind of something that's out of our control, but the other things, the other components is something we can tweak and we can increase. So we have a high likelihood of a successful attack, at least from an attacker's perspective. From our perspective, it's controlled and we collect data. A high likelihood gives us really good data. It allows us to understand how an attacker would get into our system, what he would do inside the system, and finally the tools and techniques he would use. And with this knowledge, we can adjust our viewpoint and protect our system. This is from a Chinese guy who does a lot of quotes. Thus, the expert in battle moves the enemy and is not moved by him. This kind of means that if you're reacting to security problems, if you're reacting to incidents, if you're changing your defense based on attack, then the attacker is moving you. He's changing the way how you behave. He makes you do things. With a honeypot, we can do exactly the opposite. We can control how an attacker is moving inside the honeypot. We can control what he sees, what he gets, and where he's going next. Actually, this is not something that only applies to honeypots. This is also something that should apply to your defense. I mean, if you are just reacting, if you are struggling and keeping up whatever the attacker is trying to do next, then you already lost the game. I mean, he's always a step ahead of you. But if you see what he's doing, if you can anticipate what his next step is, and you can influence his decision-making, then you have the upper hand. You can control him. You can either completely shut him out, or you can let him inside the system if it's a honeypot, or if you have enough control, if you're confident enough that you can control him, you can learn about him and see how he's moving around, and you can play him and let him waste time in a honeypot. So, as you have heard in my previous talk, I get hacked every time. Every single day, I get compromised 1,000 times. My Windows machines get exploited on a daily basis. Keep this in mind that things are going to break. Viruses are going to be smart enough to go through your firewall, go through your AV signatures. Be prepared for those moments. Be prepared that things will get encrypted and you have to pay ransom to get them back. Someone previously mentioned that malware is not the important thing you should look for, but I like to see malware still as the thing that is the entry point into a system. Even if it's just an exploit, even if it's just a dropper or a backdoor, those are the things that will open up a door and let people inside the system. Next thing I want to talk about is awareness. Awareness is something we never master, but we have to train every day. The problem is where do you go next if you have the awareness? And so I want to stress that awareness is not the only thing. If you're aware, you see a lot of things. You see that something's happening, but where do you go next? And so I want to stress that you shouldn't stop with awareness. I mean, just because you see the doors open doesn't prevent someone from walking inside. So don't stop with awareness. Teach people to understand what they see. It's not enough by just seeing the problems. It's important that they know how to react properly on seeing the problems. So again, adjust your viewpoint. It's not enough seeing the things before you. You have to see the things behind you, below you, and above of you. And most certainly, you don't know what's going to hit you next. And most certainly, you don't know enough. So be open enough that you see the whole picture. Be open enough that you ask someone else for help, and that you understand that other people have different viewpoints. Thank you very much, and I'm open for questions.
Ali. Did you eventually get your hands on PLCs?
Yes, I got some PLCs. So Ali's question is talking towards the honeypot. We use real PLCs to emulate PLCs inside the honeypot, so we can multiply the real PLCs we have as emulated systems. But still, if someone has spare PLCs laying around, if you have a PLC that we can access via VPN, so we can clone them and emulate them, I'm more than happy to have a look at them.
Any other questions? Okay, thank you, Lukas.